so that we make sure we are indeed live. But this is where we could talk a lot of
crap.
Science crap. Oh, is it you or is it the virtual you?
That's right.
God, I miss you guys so much. All right, we're live. It's on like Donkey Kong.
All right.
Bam.
Oh, nice.
Gotta give it that buffer.
Check in. Watch party. I'm doing a watch party here. Okay.
Okay.
I don't want to waste time. I'll probably mess it up and screw up and send people to the wrong channel. All right. Ready?
I'm ready.
I'm ready.
Let's do this.
We got their drinks? No?
Just water.
Good enough.
It looks like tea.
Yeah, we'll have to highlight it. All right.
We're live.
Cool. Welcome, everybody, to the 10th episode of Science Squawk. My name is Abel Gutierrez. I am your host here with the ever-present, ever-beautiful Amanda Caniglia, right?
Oh,
Can I get it right now? 10 shows
like
later.
Familia.
Our executive producer, fearless leader. Without her, none of this is possible, right? So, beautiful recreation of Bella Vista, but virtually, right? Yeah, so today's episode is focusing on organoids, and many of you have been asking since I posted up earlier many interesting questions about some really cool experiments about recreating tissues on their bodies and some elongations, etc. I don't know if we're going to go into that. Yeah, exactly. Organs. This is a
Okay.
PG show, right? PG-13. And we're lucky to have two really, really cool people, great scientists, both from the academics sector and the biotech sector, to explain how organoids are used today and kind of give us a background of how they started, what they are, and what they do, and how we use them both, in research and in the clinic potentially. And so, with that, Amanda, any things we got?
I just want to say it's wonderful. Thank you for taking the time to come on. God, Pinar, we've been able to see each other a few times in passing when I've popped up to the cafe. And Oivin, like, dude, I haven't seen you for like 3 months or more.
3 months at least.
It's crazy because these two amazing scientists are like family, and they're people I see on a daily, if not a weekly basis. So it's just nice to see your faces, even if it's virtually. And I'm excited because, as I always say, I'm busy just pouring the drinks and getting the conversation started. But hopefully you can shed a little light with Abel's help on what it is you guys actually do when you're not drinking beers at Bella V. So,
yeah, you're pouring and we're drinking, right?
That's right.
Yeah. See how that works?
Yeah, it's synergy. Yeah.
Yeah.
So with us, we have Dr. Pinar Mesci, who is coming from UCSD, the Stanford Consortium for Regenerative Medicine, from the almighty Dr. Allison Miotri lab. He was on he's been on a couple times, right? Or at least.
Yeah, he was on, I think it was the first week.
Yeah.
He
right.
was on Great Minds in Quarantine.
Seems like ages ago already, right? Like
way back in like April.
10 years in COVID years or
COVID years.
And then we also have the mayor of Bella Vista. If you don't know,
Oh my God.
if you don't know Oivin, you haven't been to Bella Vista enough, right? Good friend, awesome guy, Dr. Oivin Guicherit.
Guicherit, yes.
Yes.
Nice to meet you guys.
Or
Close
just
enough.
Oivin, or the mayor of Bella Vista. If you need a job, you got to ask Oivin. And he's coming to us from Stemonix, which is a company here in San Diego on the Mesa that deals with the organoids we're going to be discussing today. So with that, I think let's start off with what are organoids? And Pinar, maybe we can start with you.
Sure.
Your role in the lab and discuss maybe a little bit what those things are.
Sure, I will be happy to. Thank you for having me. This is very exciting. I'm actually a bit nervous. So let's see how this goes.
Don't be.
Yeah, as Abel said, I'm in Dr. Motri's lab. I've been there since 2014. I started as a postdoc. I came from France, where I used to work on mice, and I was actually working on ALS. And the reason why I came here was because I wanted to learn more about the human cells and more during neurodevelopment, what was happening there. And it seems like the perfect place to be to start learning about all this. And I did my fair share of stem cell modeling, I think, already in the lab. Had the opportunity of working on different diseases and with different cell types in the brain. But mainly this brain organoids came to be in the last couple of years. They became very, very popular, as you all know, because of their potential. Because mainly before we used to work either with one cell at a time, one cell type at a time in a monolayer configuration. But then we figured out that the 3D structures were actually mimicking what was happening in the human body much closer than what we used to have. So this is why this is a very important tool, but not only for us who are studying the brain, but also there's a lot of people working on lungs right now with probably you've seen with COVID-19, there's a lot of disease modeling happening with the lung organoids. So these are very good models that have multiple cell types present in them, and their physiology is closer to what we have in a human body. So this has implications with disease modeling, but also finding if we have a drug to do a drug screening. So yeah, these are some of the advantages of working with these organoids.
But where, sorry, like,
Lots of questions, I know.
where are these organoids? Like, and it's really hard because you were all my friends, and like trying to keep a straight face with this one right here, like, it's so difficult. Anyway, where are the organoids? Are they in petri dishes? Like, how does that work?
Yes, so basically we have plates in different configurations, so at different sizes according to what we are doing. They are basically the way that we're doing in the lab, and I believe probably in Stemonix is similar fashion. We put them in in an incubator. We basically put cells that are individually separated on a shaker inside of the incubator, and then after a while they're gonna naturally adopt three-dimensional structures. So then those structures are gonna present some of the structures that we have in the human brain that we won't be able to obtain if we were only working with a 2D system.
So I think most people are familiar with the petri dishes, and so you've got this like gelatinous material that's got all these nutrients that that allow the cells to survive, right? So you're saying that you start with the actual cell type, like a brain cell, or is that where the stem cells come in, where you turn them into?
Yes, so let me go back a little bit. So the way that we obtain this famous induced pluripotent stem cells, it's actually by reprogramming somatic cells or whatever cell. I think virtually for most of the cell types that we have in the body, from the skin or from the tooth, we can take them and then reprogram them in a way that they go back in time to when they were in utero, when we were basically fetuses. And then from that, they have the potential of becoming any cell type in the body if we give them the right guidance to become whatever cell type they need to be.
That blows my mind that you can control the cells at that level, even after, I don't know how many years. Yeah. So
order another Oivin.
Exactly.
No, the world doesn't need more Oivins.
That's right. There can only be one mayor.
That's right.
So you've got this petri dish, you're throwing some stem cells on there, you're giving it specific pixie dust, which you guys control in the lab, right? That tell it to become either, a hepatic cell or a liver cell or brain tissue, etc. So they grow up and they mimic how close do they mimic the actual organs you're trying to study? I mean, is it?
So I can only speak for brain. Unfortunately, I don't know the other organs, how close they are. But basically, we have one of the advantages, we have the different cell types that are in each organ, because that's something hard to do if you want to do one by one each cell type. It's going to be imagine if you want to have the brain, in the brain you have all the blood vessels, you have the cell types that we call glia that are not the brain cells that actually do the actual command of transmission of information, but we also have all the other cell types that are called glial cells. So you will have to do each one of them one by one, which means that you have to know precisely how to obtain each one of those cell types. But instead, if you go for an organoid option, you actually force somewhat what's happening during development. So basically, if you give them that three-dimensional structure, then they're gonna themselves evolve into with time and with the factors that we're giving them, acquiring that multicellular level.
That is great. So what is this replacing? Is this replacing like actual animals then? Is it saving animals? Are you no longer having to use mice and things like that and grad students?
So I feel like I'm kind of betraying a little bit my PhD here because I work with mouse models. So I mean, I think obviously the direction we're going towards is to working more and more with human systems, and because people have realized that with mouse models, especially for neurodevelopmental disorders, such as the ones that we're studying in the lab, like autism and so on, the mouse models most often do not recapitulate the human disease. So that means that not only we're not potentially getting the right information from patients and we don't know how to help them, or maybe a drug is working in a mouse but a human is very different, so maybe it's not going to work on a human system. So these are the main reasons, some of the reasons why working with a human system is so important. And also I guess you will go towards that later, but like all the sprinting tissues, maybe potentially replacing the cells that are degenerating in a disorder such as like neurodegenerative disorders. That's also a venue that some of the people are actually working on.
Yeah, I definitely want to put on the printing, but yeah, let's put a pin on that one. That's also another crazy topic. So yeah, I know your lab is pretty famous for this. Now, what is the deal with sending these things into space? I know I read something on that. Yeah.
Well, it's super cool.
It is cool. I think anything you launch into space, right? But what do you get out of that experiment? What was the point of that one? Yeah.
Well, besides being super cool, obviously there's some information that we want to get from that. So we realized that, I don't know if you guys are familiar with the NASA twin studies, that when the two astronauts twins, one of them stayed on the International Space Station for a year, and then his twin was on the ground here on Earth. And during this time, basically, scientists have monitored all their metabolomics or their blood work, etc., to see what will be the impact of microgravity on their general physiology. Would being in space in longer periods of time, would that induce some inflammation? Would they age faster? Would they have any type of sequelae or anything? Or maybe would they have more muscle mass, which is not the case? But so these were the questions that I guess the scientists wanted to know, what would happen in long periods of time in space into a human body. But this is a hard study to do. So in this case, there was only 2 people, which is already great. We have some hints, but we actually don't know what would happen to a human brain, for instance, in microgravity regarding its development. Would that help the cell migrate to in the right fashion in the structures? And why am I saying that? So there's actually 2 big reasons, I guess. One is, one day, I don't know if you guys are following, probably you are, NASA has the ambition of going back to Moon and then going to Mars with astronauts. So those are going to be very long periods of time in space. So one thing that we have to know before doing all that, and also in parallel, maybe what happens to the human body during those long periods of time in space. Do we need to be prepared for some kind of alterations in our body? And if so, how can we prevent that? That's one thing. And in one day, if we colonize space, this is something that Allison always says, and I kind of like starting with that because I think it's sci-fi, but one day we'll get there. If we have to give birth in space one day, if we have to go to other galaxies, and if we have that technology, how would that impact a human brain if you have to do that in space? So that's the part that is a little bit more sci-fi for now. But there could be a therapeutic potential of it. Because we don't know if this microgravity could help with, for instance, the cancer cells, to help them slow down. If we figure out how it helps, we can maybe find better therapeutics. There's also a lot of tissue engineering in space to see if it facilitates some of that and make them more optimal for human use. That's also another, we're not doing that, but other groups are doing that up in the ISS labs. And what else? There was one more thing.
This sounds a lot like that Jodie Foster movie. What was it called? Yes, right. Didn't the benefactor, wasn't he like out in space and to slow down whatever? I mean, I know we're probably like.
Actually, I don't remember that movie. I was little.
That was one of the reasons that he went out there, was to slow down the progression of whatever illness. I think it was cancer, maybe.
Was it aging? Wasn't Cocoon? I
don't know. Right. We really get into
that's writing in Spaceballs.
Right.
And a bunch of comments here. People offering to send others up to space right now.
Another thing that I forgot to mention is when we develop this brain organoids, or whatever organoid, it basically mimics what's happening during neurodevelopment. So if you want to model a disease that happens later in life, in human life, like 50 years and older, like I'm thinking about Alzheimer's disease and things like that, we might not be able to recapitulate everything that is happening at that time to a human brain. So since there are hints from this NASA twin study and also other studies that there might be an accelerated aging, this could be also used as a model, sending organoids over there to study, to model these diseases better.
So
there's a lot of applications.
Yeah, it's like I don't know where to go with this now. So many different areas. So now, okay, this is now used relatively routinely in the lab and in the academic field, or is it still being adopted? Where is it in
brain organoids?
Yeah, or organoids in general? Is it something that's widely used?
Yeah, everyone who works on in stem cells. I mean, I can speak for what we are doing in the lab, but probably also in the building, this is true, that most people are going towards organoid modeling. You might not be able to get all your answers from that, especially if you're looking at specific cellular interactions. So just the interaction between two cell types, if you have too complex of a system, it might be difficult. So for those more punctual questions, you might still need to go back to those simpler systems. But as far as just overall development of a human brain or parts of human brain for a specific for a specific disease, we can use brain organoids to already get somewhat of an idea to see what's wrong, if it's bigger, if it's smaller, if there's more cell death or less cell death. And from that, we can start making hypotheses and then study it more deeply.
So if I go back to my lab days, which are, I'm seeing a lot of steps and a lot of variability here. So how do you control for that? Is this where the companies like Stemonix fit in to commercialize a product, and so that you're making the same cake over and over again, or the same tissue? Is that the gist of it? Or Oivin, can you fill us in on how Stemonix fits into this?
Sure. Yeah. So, as some of you might know, so Stemonix is a stem cell company that essentially specializes in these, what we call stem cell derived, the same type of cells that are developed in the Motri lab. These stem cell derived, what we call cultures, and we use them more for drug discovery, right? So there's really two big areas you can go with these stem cell derived cultures or microorgans or microtissues, as they're called. You can either go into the drug discovery or you can go into regenerative medicine, right? And so Pinar touched on this a little bit. But you touch on a very important issue right there. So the industry has a very different set of metrics that they measure these platforms by, because in order to do drug discovery at that level and with the rigor that we have to do in the industry, as you said, we need to have things that are highly reliable, reproducible, robust, and they should perform the same way over and over again. Now, there's a lot of excitement around these organoids, of course, as Pinar already explained, of this wonderful human biology that we can now mimic in a dish, so to speak, right? What we couldn't do before. The problem often is every single little organoid you make is almost like a little individual, right? The shape, the size, the cell types, the cell composition are not quite exactly the same. So if you have to go into drug discovery in the industry where we want to test lots and lots of chemicals that we then throw on these, let's say, these cell cultures of these now stem cell derived microtissues, microorgans, and we look for chemicals that give us the right readout of biology. Imagine if every time you put a chemical on a sample like this, it's a different sample. Now it's hard to then interpret the result of that, right? So you need to ensure that the samples you're testing against are highly reproducible from sample to sample to sample. And so this is where we often make a distinction in the industry between what has been often referred to as organoid or what we like to refer to as spheroids, right? So we make that distinction right up front so that people understand. So an organoid tends to be a little more of a complex, if you want, system, a sample. It much better mimics the tissue or the organ. That's why we call them microorgans or microtissues. But as I said, there is less control over consistency from sample to sample. What we do is we make organoids where we don't quite maybe have the same complexity. We do have enough complexity in that we have multiple cell types, but in the spheroid, the cell types, the cell composition, the size, the readouts, the functionality is precisely controlled. So that every time you go back to that sample and want to test something new, you can compare against what you've done before. While if you do that with organoids, and as I already said, every sample is different, it's like trying to test something on different people. Well, everybody responds differently, right? So imagine if I were to test lots of chemicals against 100 Abels, I can interpret one versus the other. But if I were to test it against 100 different people, then it's much harder to interpret, right? And this is part of the challenge, by the way, in the industry in doing drug discovery and development, right? Eventually, you develop a drug that needs to work across thousands, 10,000s, a million people. But everybody is different. Everybody's genetic background is different. Everybody's biology is different, right? So that's part of the challenge. And there's so no different in these stem cell-derived cultures. So we work more with spheroids rather than organoids. And really the difference is it's slightly less complex. It's still complex enough, but it's really about consistency, robustness, and reproducibility.
So I guess the same question. Do you how well accepted is this this format or this platform now versus like say 2 years ago, 5 years ago?
Right. Yeah. No, exactly. A great question. So, first of all, I have to say, I am not a trained neuroscientist. And our main platform is neuro. So I learned quite a bit over the last 3+ years that I joined Stemonix, unlike Pinar, who's an actual trained neuroscientist. So when she speaks about these things, she actually knows what she's talking about. I just pretend I know what I'm talking about, okay?
Sounds good. It sounds good.
It sounds good, right? But no, so, the thing is, it's created a lot of excitement, right? So if you think about it as an example, right? You want to test, you want to screen for something, discover something, test something in a lab, and you want to develop it for a neuro indication, a therapeutic, and for the brain, for the nervous system. You want to be able to test it on something that has similar biology, right? Back in the days before these cultures were available, there were not such easy things like neural cultures, right? Imagine you can't go to somebody's brain, take a biopsy, and turn into a culture, right? It just doesn't work. Right. So before these things were available, these now what we call reprogrammed stem cells, you had to rely on other cell types and other, organisms. And we often in the drug industry, as you know, we use a lot of rodents, mice, and rats. But that's not a human. Right. So we really worked with much more what I would call artificial type systems that didn't really reflect the actual tissue and biology. Right. Now with these stem cells, that you now can program into any histology, any tissue, you know, practically any tissue nowadays, right? We've come a long way. Now you want to make, you know, a culture that represents cardiomyocytes or a culture that represents neurons. You know, you can take the stem cell and with the appropriate cocktails, as you pointed out earlier, and Pinar pointed out earlier, the appropriate cocktail and the magic pixie dust, as you said, you can actually push it in a direction that you like and actually make these cultures that now better reflect human biology. Right. So that opened up a whole new world, as you can imagine. Right. So no surprise that several years ago, you know, a Japanese professor who came up with this reprogramming technology first won the Nobel Prize. Right. I mean, that was a no-brainer at that time. Right. Because imagine the impact that has throughout not only the industry, but the whole world. Right. You know, in academia, in the medical professions, and in science and the biopharma industry, it opened up a whole new world, a whole new set of possibilities. Now, having said that, you know, the industry doesn't quickly accept these kind of things, right? It needs to really prove itself. And so, you know, stem cells have been around actually for quite a while. And this ability to do these reprogrammed stem cells and then make these different tissues have been around for a while. So there's a lot of excitement in the industry because it opens up so many possibilities. But the way I explain it to people, it's like, you know, we're all still learning how to best use them. We all still learn them how to best, where do we best position these platforms so that the drug discovery process becomes more efficient, you know, and more, you know, how you call it, you know, we shorten the cycles so that, you know, it doesn't cost as much money to develop these drugs, but also we do better, right? It's one thing to be able to develop lots and lots of things and then, as we like to say, right, throw crap at the wall and see what sticks. Now we want to get more, you know, we want to be smarter about what we do up front so that by the time we get to the more expensive clinical development of the drug discovery process, that we have a much better chance already on success. And by incorporating these now stem cell-derived human type platforms, this now allows you to be more successful down the road. At least that's the promise. Having said that, you know, there is not a lot of examples already out there because everybody's still working on this of where we've taken it from A to Z and show that thanks to these platforms, we've been able to, you know, been able to better develop drugs. So there's a lot of excitement, but as I like to explain to people, it's like the industry, we're all still playing in the sandbox. We're all still trying to figure out what we can do with it, where we can fit it, you know, how we can use it. Definitely a lot of excitement, but we're still learning. And it's kind of like, you know, remember the early days of immuno-oncology. I remember when I, you know, started a job long time ago, I won't date myself. I remember walking in the door, the first thing my mentor said, immuno-oncology is never going to work. This is terrible stuff. Yeah. Who thought that immuno-oncology could work, right? And look where we are now. You mention immuno-oncology and people throw money at you, right? Because it's such a powerful, you know, technology now or an approach that we didn't believe. And so it's the same thing with the stem cells, right? Or the stem cell derived cultures, right? So there's a lot of excitement. We're learning a lot and, you know, we're making great progress, but we're not quite there where we can point to a lot of examples where these things have specifically improved or expedited or made the process more efficient in some ways.
You bring up a couple points there. You know, I know we talked about iPSCs, the induced pluripotent stem cells, right? These are not embryonic stem cells, right? And I know there's the whole ethics question and the issues that kind of surfaced when Sanford Consortium was first being built up. Are you still facing a lot of those challenges from the public and funding as far as getting money for stem cell research? And how can I put it? Is there more of a future for using embryonic stem cells now?
So I don't know, Pinar, you want to go first?
Yeah, I was going to say regarding the ethics question, that's an important point that you're bringing up. So I think it's right now it's kind of a trade-off where, especially for us who are working on the human brain, which is a previously inaccessible tissue. So even if like there are a lot of tissues in the human body that it will be less invasive to go in to see what's happening in the cell or in the organ, but in the brain it's much harder unless you have some kind of reason to get in there. You don't usually go in healthy people and open their brains and pick that up. So that's where the iPSCs and the brain organoid modeling is very important, because now we have some kind of a glimpse of what's happening and what might be happening in the human brain. But then regarding the ethics, there's actually Alison organized a meeting that was super interesting regarding the ethics of brain organoids and whether they would have a consciousness possibly or something like that. And this sparked because of a colleague in the lab who actually developed with his wife Priscilla, who's now actually working in Stemonix, these brain organoids. But what they have found is these brain organoids had some features of electrical activity resembling to a preterm baby.
Wow. I remember that.
But
Yeah.
then does that mean that do they have a consciousness? Are they now feeling things? Should we proceed with caution? What should we do? So in the light of all those questions coming, Allison took the leap forward to kind of already ask these questions, because these are probably questions that will come in the future. As of right now, I don't think that we have anything to worry about, because we do not have the structures that we know of that are creating consciousness in the human brain, although we might not be aware of everything. But right now it's not a concern, but the more we try to be the more and more reliable to what's happening in the human brain by adding, by making it more and more complex. For instance, adding blood vessels, adding a spinal cord in there, adding the muscle junctions, or when you make more and more complicated, maybe those ethical questions will also start to be a worry. But then we have to, as a society, as a scientific society, and then as the public, we have to address these and then move forward all together, I think.
And I'm glad that you're saying that he took that proactive stance, because I think a lot of times, you know, as scientists in the community, sometimes we don't do enough early on, and we don't get in front of the message before it hits the public, and then that's where it gets twisted, and then everybody looks like the guys in Jurassic Park, right? This is what you guys are doing. You guys are making raptors, and you know the world's gonna die, something like that, right? I mean, that's unfortunately that's the level of science sometimes that people have, and that can then morph into something really bad, right? And it's hard to dispel those situations, so or that mentality.
Right.
So it looks like it's also paralleling that the same kind of ethics questions that coders have to deal with, right? Where it's like at some point, is the code that you know people are writing that for AI, at what point does it become sentient, right? You know, so this is you're just doing this biologically, and at same kind of thing. The more complex it gets, at some point, at what point does this become, you know,
Right.
a conscious thing or being? But
Right.
now, as far as the embryonic stem cells, now has that died out? Is it still used, and what situations are those still used in, if at all?
And is it being used? I was just curious too, like, is stem cells being used more now as we're searching for a cure for COVID, as we're searching for a vaccine? Are stem cells even a part of this process? I've seen people say like, oh, stem cells will help cure it. As marijuana, you know. No, but are stem cells, what role are they playing?
Well, I mean, there are so many publications regarding COVID right now, but I think besides the ones that are directly on patients, there's actually a lot of them also on different organoids that are coming out, about kidney organoids, lung organoids. So people are looking into whether this receptors for this virus can be present in those organs as well, to kind of predict or potentially explain some of the symptoms that these patients might be experiencing. So yes, I mean, stem cells and organoids are being used as absolutely in every field. This is, I think, very exciting times to be working on this, and the potential of it is so big. We might not be there, as Oivin was saying, like there's still a lot to figure out. We might not be reproducing, it's not as reproducible as possibly we would like it to be. There's still pieces, imagine like a piece of puzzle, there's still some pieces that are missing, but right now science is growing at an exponential rate. So I mean, I think in a couple of years, we're probably gonna solve all this. And
one say it's growing 10x.
Not being paid by
Since he's the host, we'll allow it.
I know, right? So you know, this kind of takes us to the more complicated, I guess, models using 3D printing. Like, you know, I've been asked this a lot when I talk about it to, you know, my friends that aren't in the sciences. Like, at what point do we start to print tissue? or biological band-aids or blood vessels or things like that. How far are we from where you're at now and those expectations that the public has?
Oivin, do you want to start?
Yeah.
Stemonix going to make this stuff.
You guys are
Amanda, what do you think?
Are you printing out organs? Like, honestly, how does it?
So
the future?
what he's referring to is that people now have been able to actually turn what looks like standard printers, and they can actually now print down cells, so to speak, and turn it into a 3D structure, right? Into that looks like an organ. Yeah, it's going to be a combination, right? So these stem cells, if you think about it, right, this whole reprogrammed stem cell that we have now access to allows you essentially to make every single cell type in theory, right? Some we make better than others, some we can make more reproducibly. So now, because if you want to print down an organ, right? So where the printing might come in is that you have maybe a little more control over the structure, right? And how you build that 3D structure, right? How you build the layers. But there's obviously multiple cell types in there, right? And some of those cell types you can get from maybe harvesting through biopsies from, primary human tissue, but in a lot of cases you cannot, right? So by now combining the two technologies with having the ability to now make, in theory, every cell type, and now combining that with a printing technology that now allows you to build things in 3D, now I think we're starting to really get in this realm of one day hoping to make, actually total organs. And, I don't know if you've seen, and Abel, you know this, that people have already been publishing papers where, they would make what they would call maybe mini versions of these organs. So people are able to take these cell types now and structure them in such a way that it actually looks like, an actual liver or an actual heart and things like that. Obviously, we're not quite where we can make them of the size and functionality that we can now do organ, transplantations, but we're not probably very far from that, right? As the technology is skyrocketing, as Pinar and you guys were saying, that together with, think about it, right? The more complex things get too, the more amount of data you have to deal with, right? And so, but now with computer technologies and with machine learning and AI, now we have the ability to deal with complex data that we couldn't do before. So all those things together makes for an incredibly exciting time in science, right? Now, things that we could just dream of or that we only saw on Star Trek, we can actually start to envision, right? That these things might become real one day. Yeah. So it's a very exciting time. I agree with Pinar, and we like to joke in our world that we live in a 3D world, right? So we moved away from these simple, artificial culture systems where we grow a nice monolayer of cells. Now we're going to more complex, right? And we call them 3D type culture systems, right? And we very much live in a 3D world. You cannot talk to a lab or a company, small or large, that is not already, somehow using these type of 3D spheroid organoid type platforms, right? Because now that we can actually mimic better human biology, right? You'd be a fool not to go do that. Now, that doesn't come without its challenging, of course. The more complex you make something, the more complex also, the results that come out of that. So now we run into what I like to refer to as a deconvolution challenge, right? So now, how do I take now that complex data I'm creating and try to somehow boil it down to understanding the underlying biology so that I can make some real logical scientific, decisions, right? But again, right? But because we now have the ability with machine learning and AI to manage this complex data, now again, bringing all this together opens up incredible new opportunities, a whole new world. So absolutely an exciting time to be in the world of spheroids and organoids, no doubt.
So we're talking about all these cutting edge technologies. How much of this is being taught at the undergraduate level, at the graduate level? Is this something that people can, if they're listening to you, Pinar and Oivin, like, oh my God, I want to be like them when I grow up. Is this something that you learn later on in life, or can you now take classes, courses that kind of gear your career towards that?
Good question.
That's a great question. Unfortunately, I don't know a lot about I know what my students tell me from what they have as an option for classes. I know that for certain electives for like organoids and so, like I know that my boss, Alice Motri, he just gave one about the genesis of different organoids and all this different cell types in it. And he also gave us an opportunity to give a class about our favorite cell type and the brain organoids, to kind of tell them about how they're being generated and so on, like give some protocols and some applications, etc. But I think right now it's still more like in a conference type classes. I don't know how much of the theory they're getting. I'm not sure too much. I think it depends on what type of classes they choose. But I think in our building, especially Allison is always very open for people to come and visit. I mean, we've had always high school kids or literally everyone at all ages have always come to our lab to kind of see a glimpse of what we're doing. And I think we're always happy to show them what we are doing. I certainly enjoy it a lot. I know that Allison does that a lot, and he also enjoys it a lot.
But to be fair, I think that you're in a very special lab and a very forward-thinking lab, both, how, Allison thinks about the community and education. I think so many scientists are still very laser focused on what's just in the lab, that it's still, at least in the past, I've seen it to where it may take 5 to 10 years before new technologies and platforms actually make it into textbooks. So
Right.
I don't know if that's changing. Maybe even you've seen some of this.
No,
much of it, but.
Yeah, I think it's definitely improving. I have to admit, I'm always shocked to find what kids already learn nowadays, in high school and especially even already, and of course in college. I'm helping out on the board of more like an advisory board at Southwest College down here, and they have a biotech program. It is amazing. If you see what these kids learn already at that level. When, back in my days, right, back in the Middle Ages, we had no clue, right? I remember, remember the days of green fluorescent protein, that was like nobody even thinks about it anymore, right? We all talk about it like it's a normal thing, but back in the days, and I remember visiting a high school, and they said, we want to show you our academic programs, this and that, and just so you know, we have a couple of programs that are geared towards a 4-year degree in college. And here's some of the things they work on. And I walk into the room and there's this big poster with all this green fluorescent protein staring at me. I got this. I think I didn't hear about that protein until I hit grad school. Forget undergraduate, right? And I saw this in high school already. So no, I'm absolutely convinced it's getting better and better and better. But you're right? We need to be a little more aware as an industry and as an academic, arena, that we need to be more integrated and we need to pay attention. What you see a lot, for instance, right? Things move so quickly, technology develops so quickly, and then we find there is gaps developing because, the universities are not keeping up with training them for the appropriate jobs. Think about nowadays, right? Everybody needs to know Python if you want to do anything nowadays, right? I'm like, what the heck is Python? Right? I had never heard of this thing. But nowadays, any job you want to get that involves any kind of computer or computer language, if you don't know Python, they don't even look at you. Well, it turned out a lot of kids were not trained, early on in their career to do, so what happens is they get to a certain point, they check off all the boxes, but they don't know Python and the company doesn't want to hire them. Right? So then what happens is companies got smart and the whole industry got smart. And because there's much more connection now between the academic world and the industry, they actually now actively promoting these type of programs where they teach you this more advanced stuff so that by the time you go look for that job, you actually have something to offer, right? Even if you don't have industry experience ready, but you have at least some relevant training, right? While there was too much of a disconnect back in the days, and it's much better now. We're not quite obviously there yet, but yeah, it's amazing nowadays, when these kids come in, what they've learned already, which again, back in my days, when I went into biotech, for instance, I had heard the phrase biotech, but I had no idea what it was
like
getting
one
into.
company back then, right?
Sorry?
Just
yeah, that was
it's like Genentech.
They had one, called Genentech, exactly, right? People say the biotech industry. I'm like, you mean Genentech? Come on, right? Nowadays, it's like you can't turn around and there's another company popping up left and right, right? Yeah. So it's a different world. But you're right. It's important that we do pay attention to, the industry, and that we really pay attention to, what it is that they teach in these kids, and make sure that it's more aligned with what ultimately these kids, will end up doing in their jobs. So
more specifically, what I'm hearing, okay, if I was an undergraduate now and I'm listening to you guys, what would I do to get into your field? What degrees? Because I also know that Jerome was on the show talking about you know, what to do with your PhD, you know,
Right.
academia, and I know he has a nonlinear path that he took, and he was an engineer, and he was, you know, learning how to print or teaching or creating ways to print tissues, or I forget now, but it's you know, totally not something that I would have thought would have been like something that would have appeared in your lab. So where does, you know, what fields are opening up because of this platform, this technology, and what can someone like at the undergraduate level do to get there from here? Does that make sense?
You know, again, I think it's as Pinar was saying, right? You need to be aware, you know, and they are more aware sooner than later, right? I mean, I remember, you know, when I went to college, by the time I think I graduated high school, I finally gave it some thought. Oh, what am I going to do in college, right? And by the time you finish college, you go like, oh, wait a minute, I need to go to grad school. You know, what's this thing? So nowadays, I think they're much more aware. And also because they're more connected, and like I said, the industry and academia is more integrated, they are more aware of what's possible and what's out there. And by also the appropriate networking at places, I don't know if you heard of this place called Bella Vista. It's a phenomenal place to network. You know, you learn some things, right? So because we are much more connected, right, they can sooner be made aware of where they want to go with this. But you know, you touch on very important, right? None of us, and you've had the same, and I'm sure it's going to be the same for Pinar if she ever leaves Allison's lab. I don't think he's ever going to let her leave. But that's
I know. I think he's holding on to.
Right. Exactly. Right? Exactly. Well, we managed to snatch 3 of their people already, so we're waiting for her to finish up because we're creating an opening for her. Just so you know. But yeah. So you know, the thing is, right? None of us follow a path that we thought we'd follow, right? Especially in the industry, right? You know. If I look at where I started, I mean, look the same for you, right? We all probably started in a very similar way, and we're in very different places now, right? In my case, you know, between biotech and pharma and CRO, between R&D and business development, I mean, I've been all over the place as well, right? You know, as my mom likes to say, she's waiting for me to grow up, but that's a different story. We'll talk about it some other time. But you know, so it is absolutely the case.
Dr. Katch.
Yeah, it's absolutely the case that you never follow a straight path, right? And that's what's interesting about it nowadays too. It's like, you know, it's back in the days, if you look for a job, people want to know what exactly can you do or can you not do. Nowadays, it's more about, are you the type of scientist I can rely on, right? And are you the kind of scientist that can adapt? Because I can guarantee you, we hire you for one thing and within 2 years, you end up doing something different. Right. So it's really about you more as a person and your ability as a person, as a scientist, rather than I'm really good at Western blots. Who cares? Right? You're a good scientist. We can teach you how to do Western blots. Right. So it's a different world in that respect. But you make a good point. In the industry, that's the thing I always explain to these kids, right? Because they always obsess about what exactly do I need to be good at? You just need to be a good scientist because you're going to come into this world and you're not going to end up doing the same thing in a couple of years. So it's really about good, solid hands, good head on your shoulders, you know, and being able to adapt, and then you're fine.
Yeah. I think they have to be very interested, like right off the bat too. You know, I mean, I understand what you're saying, like with all these technology, what the kids should do. But as Oivin was saying too, like everything is developing right now, and nothing is really set in stone. Everything is developing as we speak. Every 24 hours, maybe things have already changed. You know, so then if I have an advice, would be like be as interested and motivated as you can be, because right now we're already living in a world that everything is accessible. Like all the information is accessible, so then it's up to you to do the triage of that information and try to reach out to people who are leaders in their fields. And I know that Allison's getting a lot of those from like a variety of types of people trying to understand what we're doing in the lab and so on. And also it's up to us a little bit. And I know that us in the lab, we really like doing that. There's a lot of grad students like to do a public outreach for high school kids, or, I mean, Allison does all these different videos as well online. This is my first time, but I'm enjoying it a lot. And I always love to talk to people and to young people, to high school kids, to teach them about what we're doing. But yeah, I think if we do more of that, and if they show interest and try to follow what's happening, I think that's how they will probably get where they want to be.
Right. I mean, it's really about passion, right? I mean, this is not a profession that is for the faint of heart, right? I mean, we look, nobody goes into science say, I'm going to be, rich and powerful one day, right? Yes, there's a few that have become rich and powerful, but you know how many of them have not made it? I mean, it's just a tough business to be in. But the reason it works for a lot of us, we are so passionate about this, and it's so much excitement, right? I mean, come on, man. There's a reason when you look at the world of the future, right? Whether it's Star Wars, Star Trek, all these sci-fi, everybody's a scientist. Why do you think everybody's a scientist? Guys, it is the most exciting job in the world, right? That is we're the pioneers. We're coming up with all the stuff that everybody else eventually uses in daily life. I mean, it's fantastic. If you're not passionate about it, you're not going to make it. It's a long, hard road, but it is so much fun along the way.
That's one thing I noticed was just because I'm, with the cafe, I'm there 7 days a week, and I was never the scientific person, but I had so much newfound respect for all of you, because I'm there at 10 at night, 7 in the morning, and I see you guys come in 7 days a week, all hours of the day. And I didn't realize how, like you're saying, how much passion you need to be in science. Yeah. I think a lot of people out there think it's quite the opposite, that you're a person who's robotic and you do things and it's very limited. So I think there's just a huge misconception, and I love that you're sharing your passion with people. And I think it's important for people out there to know that you guys do not stop. When others are out there having a weekend, I'll see Pinar come or other people from the cafe that are in the building, and I'm like, what are you doing? Oh, I'm checking on my cells, or I'm checking on my lab. And it's just the amount of commitment that you guys put forth is amazing. And I think it's also interesting because I always bring it to like relationships, but I find that a lot of scientists end up dating or marrying other scientists because your lifestyles have to align.
There's a lot of that, quite a bit of that.
I think like you have to be, you have to find someone who's gonna be accepting of the passion, or who's gonna be right there, on board with you.
Right. Yeah, no, but as Pinar says, right? I mean, as you said, when you work with live material, it's tough enough. But when you work with live material that is stem cell derived, as she will tell you, as she's still in the lab with this, I mean, it's like a daily routine. Stem cells, one have tender love and care every single day, right? It's not like you feed them one day, you go away for a week, you come back. These cells need attention every single day. If you treat them right, they will do the most wonderful things for you. But you screw up and they will go down the wrong path, you can start over. So, and of course, nobody wants to keep starting over, right? So you learn the hard way. You got to really keep at it. And but again, it's really, as they say, a labor of love, right? You really need to have that passion. You need to be into it. But if you do, again, it's not an easy road always. But it's the little rewards that we get along the way, and again, right, you will see with scientists, sometimes it seems like a little thing to people who don't understand the world, and we get really excited about it. But it's because of those kind of highs along the way, you can make it work, because it's a long road,
And again, we don't want to get into politics too much here, but
or at all. Okay.
Bring it. Why not?
Bring it.
Show. Woo,
get it right now.
It's at some point too, right? The standard of living has to at least be, you don't want to have 12 postdocs living in one room, right? There's passion and then there's stench, right? Yeah. So you want to at least have them be able to have a decent quality of life, right? Yeah. So where the point, where you choose to go into sciences versus choosing to work at Target. Not that Target's, you're, being a bagger is bad, but to see, 3-4 years of experience there and you're making more than somebody who's, 10 years in the lab, it's a little disheartening, right? And you can eventually some of that passion gets killed, right? Or, you start to hear, the world is becoming a little bit more, I guess, consumer based, right? I want to have this, I want to have that. And so kids are growing up thinking, I want to have all these things and I can't afford to have them if I go down this road. So they don't become scientists. So we have this lack of scientific talent, right? So what do? We get the H-1Bs from around the, internationally, and we fill that gap, and we've been doing well with that, right? With the recent development, no more H-1Bs, right? I mean, what what happens? I already know there's lots of labs that stop projects because like so-and-so is not coming from Germany, so-and-so is not coming from France, and nobody wants to come to the lab. So projects grind to a halt. So how do we fix that, right? What's the short-term and the long-term solution there?
Well, I have a short answer that was very non-politically correct, so I probably won't go down there. But you know, it's a very unique world in that respect, right? All of us. I mean, you know, again, when we meet up, you know, at remember that place, Bella Vista? I've heard about it. When we meet up there, you know, you look around the room and it's very international, right? It's fantastic, and it's especially in the science world like that, you know, and. You know, I'm not sure exactly how it became that, but it really opened up the doors to a lot of us, right? And so to hear these things that, you know, visas get put on hold, there's a lot of restrictions now, people can't come in. It's a really a bad thing for many, many reasons, right? Because the whole science world in this country, right, where science is top notch, right? The most powerful, you know, country in the world. We have some of the best science, if not the best science in the world. People should not forget, a lot of that is built on the backs of immigrants like ourselves who came in, who made it happen, right? So to now suddenly stand up and make these crazy claims about, you know, and then putting restrictions, I mean, it's just absolute nonsense, right? It's naive, it's ignorance, you know, it just doesn't make any sense, right? And, you know, hopefully these things kind of come and go, right? These things don't last. Because again, right, I like to point out to people, as you said, right, this industry, this science industry is built on the back of immigrants. Look around, there's no other industry where it's so international, right, than this particular industry. And it makes it why we even love it even more. I mean, you know, I meet people from all over the world by just going to this one place. I don't know if you heard about it, Bella Vista.
Yeah.
I'm gonna drink every time.
So, you know, I mean, it is a fantastic world to be in for not just career and scientific reasons, but also for personal reasons, you know, relationships, as Amanda mentioned. I mean, the kind of relationship you can build by having this international community. I mean, it's fantastic, right? So we should do everything to not only keep that going, we should promote that. Right? It is nonsense to try and restrict that, right? It doesn't make any sense. Anyway, and I'll stop at that. Pinar,
you go. I mean, for all of us to advance, you know, to have all these creative ideas and so on, I mean, you have to bring people from all different backgrounds, and also let's not forget that, I mean, all these people coming, I mean, maybe I shouldn't even be saying this, but I mean, we are all highly skilled people. It's not like, you know, I mean, I guess everyone is replaced in every job, but, you know, everyone comes with a specific skill set. And, you know, in this lab, Alison has invested in me for the past 6 years, and I've already acquired a specific skill set that might not be as easily replaceable. I mean, it's the same thing for Stemonix and everyone who works there. And I think we need to have this diverse background for us as scientists to advance and make all these major breakthroughs. I mean, this is my third country here right now, because I was born in Turkey, and then I lived in France, where I did had my education, bachelor's, master's, and PhD, and now I'm coming here. And in each one of these different places, I mean, you always have, especially in the scientific world, people coming from all over the world. And this is, I think, what people likes the most. Even now, when you go to a scientific meeting, there's people coming from all over the world. And this is how you do exchange of ideas, come up with new things. And yeah, I think it's extremely important. So hopefully everything will be fine.
And it lends to the collaboration, right? Because, you know, Stanford Consortium and the San Diego,
exactly,
you know, is known for collaboration, right? And so you have the spirit of collaboration, and then all, like you're saying, just this cross-pollination of not only minds, but international minds that are coming from a different.
Well, plus, you know, the way I always explain to people, you know, you have a much better perspective on everything, I think, on the world, right? If you've lived in different places, experienced different people, different cultures, you know, look, we tend to, in general, in this country, we tend to stick to our own little region, our own state. Maybe we venture out to one particular other place, we come back, right? I've lived in this country in more places than probably 90% of the Americans, right? Because they, you know, and it's understandable. People tend to go where the families are, or they maybe venture out for college or for grad school or for some, you know, job, but they end up coming back, right? So people tend to stay in one particular area. And I was amazed to me because I said, you know, here we have this wonderful country, right, with 50 different states where you can experience all this wonderful stuff, you know, and speak the same language, kind of, right? And people don't go visit these different states, right? But it's wonderful. I mean, I'm the same as Pinar. I grew up in South America, then went to Holland for my studies, then came out here. And I tell you, I would not give it up for anything. It has been an amazing journey. I've made so many friends. I've learned so much along the way, and it gave me a much, much better perspective on life. I think everybody needs to experience that.
So on the funding side, what do we do there? Because like, if you parallel this with, say, the Silicon Valley, right, where
personal funding or general,
just general, you know, money in biotech and life science.
Because I could use more money, but I'm just asking.
You know, because I hear, you know, coding, software, all that. You know, it's like there's such a demand for all these products that require software development, computers, that where you can be like the worst or mediocre, you know, coder and still make a significant amount of money. Whereas in the scientific community, you've got to be like cream of the crop, best of the best to get that $40K a year postdoc, you know, salary in your 30s. How do we change that process? Do we revamp that process too? Does that the graduate and postdoc process have to change or evolve?
Do you think it starts at the top with perception, as like is society valuing science just the way, like I come from a teaching background.
I was trying to pitch a side. That was where I was going.
Okay. So I mean, yeah, I was a teacher, and I mean, talk about not being paid enough for that job, right? Which is why I opened a restaurant.
So much easier. You make so much more money.
You can never get rid of me and Oivin, right?
That's right.
Midnight, get out of here.
Yeah.
I know, you guys close up for me.
We got the keys.
So, I mean, for me, it seems like it starts at the top. You have to change the perception of society, and, you know, for people to understand and give value to what it is that you guys are doing, right?
I think you're absolutely right. And I think maybe COVID may help. That's where I was going, right? The value system, right? Our values are placed in the wrong, you know, we will invest a bunch of money to get the next iPhone out, but maybe not the next vaccine, right?
Yeah.
And well, now that there's a pandemic, maybe that'll shift, maybe that'll change, you know.
Right.
Maybe we'll get some like research shows like ER and have Oivin be like, you know, the star, and, you know, running in the lab 24 hour, like Kiefer Sutherland in 24, but for that vaccine, you know.
Yeah.
And I also think, like Amanda is right, like maybe the public doesn't know enough about what we're doing. So this is why the public outreach is so important, because I try to tell people around me what I'm doing, and everyone whom I tell, they always get excited. Oh my God, you guys do all this. It's just, I think people don't know enough, you know, what postdocs or people like me who work in the lab, and then they just say, oh, okay, you're just doing whatever, and then we don't care maybe until there's a pandemic, and then now, okay, when is the vaccine coming up? And it's like, okay, but it doesn't work like that. We have to be prepared. And
we hear the wrong things, right? And I know I was joking about it with Mitch Cronenberg about you know, when that first show, and I asked my friends, like, what do you want to know? Like, what can I ask? And they're like, oh, ask them if they're making raptors and using CRISPR to make dinosaurs. I'm like, you freaking idiot. Like, like this is actually what they think though, right? They hear CRISPR, and that's an actual really powerful tool and technique. But, you know, Jurassic Park makes it sound like, oh, this is the evil stuff that's going on. And do we really want to go down that road, right? So.
See what happens when the park is not ready to open back.
That's true.
Yeah.
They're going to CRISPR Mickey Mouse at Disneyland, right? Sorry. But so that is a lot.
Quarantine, Abel.
So these are the kinds of things I think that we have to do. Part of the reason that, you know, I've been wanting to do this type of show with, you know, when Amanda asked, I mean, you know, it was always in the back of my mind. I think Sumit Chanda had also talked about doing something like this for years. And so just little bites, little bit, little by little, and to help disseminate this information to the public and really show how cool these things are and how important these things are, because we don't have like an Apple or Tesla type of big conference that everybody tunes into, right?
Right. But it's tough, right? I mean, it's not like in science we make a product that they can hold and feel right away, right? So if you think about it, right, they say it takes, right, was it 10 to 15 years to develop one drug and the tune of $2 to $3 billion. But of course, there's a lot that goes into that measure, right? But when they hear that, right? So, I mean, it's just hard for people to be able to relate when they're not in this world, right? But to your point earlier, it's like in every world like that, right? Supply and demand. Right now, the hot thing is computers, right? If you can code, if you can do anything on computers, they have jobs waiting on you. That's just the way it is. Well, for us PhDs, think about it nowadays, right? They said there's 5 times more PhDs coming out or postdocs coming out than there are faculty positions, right? So only 20% of the people that go through this long, long road of an undergraduate, a graduate, a postdoc. I mean, by the time I had my first job, man, I was almost in my mid-30s, right? And then if I then find out there's only 20% of us that can be placed in an academic position, I mean, if the biopharma industry didn't exist, dude, I'd be picking apples. I don't know what the heck I would be doing, right? I mean, or maybe working in a restaurant like Vista.
Yeah.
So it is tough, right? But it's but thankfully with the biopharma industry now, and there's many more opportunities, right? Plus nowadays, I think where eventually people start to value, they realize that a PhD is more than just somebody becomes a scientist. It's a type of training, right? Somebody who comes out of a PhD and a postdoc, is the type of person who can handle certain things, is a type of person who can think a certain way, is a type of person who can handle certain challenges, right? And that's why back in the days, right, there were lots of different positions that people would hire you for, even if you didn't have the training. It's harder now because there's so much competition. So that's, unless you have some of the training, it's hard to get in. But, I think people did get to appreciate eventually the level of what comes out of that. But it's hard for the common man, so to speak, out there to relate to a scientist because, it's like I said, it's not like we're making an Apple phone that they can kind of hold and play with right away, right? What we do takes a long, long time. Of course, when we finally get it, it's life-changing, right? The medicines and the drugs. But, and because I get the same from my family, right? Like, when's the vaccine coming? How much longer you guys need to mess around with this stuff, right? I saw this article that, such and such pharma is working on vaccine. Can I get it tomorrow? No, you cannot, right? But, how do you explain that, right? It's hard. It's hard for them to comprehend that this takes years and years and years to do it right. It's just the way it is. But when it's there, it's life-saving. It's life-changing.
Yeah. Americans have such problems with delayed gratification. And, I mean, my son, Leo, he calls himself out. He's like, I'm from the new generation. We have zero patience.
That's right.
Yeah. Everything's click, click, click. You get it, Amazon, Uber, Grubhub, all that.
What's the challenge sorry, I just have another quick question. A lot of times, the discussion at the cafe is about the challenge when you are coming from the academic world, having to have the role of being a PI, right? And how you want to just focus on the science, and you're passionate about the science, but then all of a sudden you're like, wait, I've got to manage people, or I've got to, my life is now away from the science, management or grant writing. Can you talk about that first? Just kind of clarify or explain.
Yes, I mean, we're scientists, but we're still people. So then we all have to, it's like a little symbiotic relationship between all of us, right? The better it is, the relationships, faster we can grow, faster we can do projects. So, I mean, definitely that's having a good lab environment and good relationships where you can rely on people, I think is very important. And especially for people like us who work on stem cells. I mean, as you said, we're here 24/7. I mean, sometimes we see people that we see in the lab much more often than we see our own families. So yeah, I mean, that's very important for you to have that. And I mean, of course, sometimes there are things that we get, a bit angry, a bit whatever, but then I think it's about communication and trying to solve that all together.
you
And
have
I think most of the time we're doing fine.
well, I see you guys have like a strong team and a strong culture, but where do you learn those skills when you're talking about gaps in science or in education, or making the leap? Where do you find those managerial skills? Because I know, like, I was a teacher, I had like complete autonomy, and then I opened a restaurant and I'm like, wait, like, why aren't you self-motivated? And I have to like manage people and be a leader. So where are you finding those skills? You think they're just inherent, or is there a mentor, or what would you?
I think, I don't know if I'm a good relationship person. I like to think that I am, hopefully I am, but I think most of it comes from understanding being an empathetic person, right? See who needs what type of motivation. I think that's the thing that I learned the most. Not everyone is like me, because also like that, this is something that I realized in France versus here, it's very different. Like the motivational things are completely different. Over there, it's like there's no time for it. Like it's hardcore. Okay, it's like brutal at times. You have to get over it and then get back. Like it has to come a lot from within you, but you're still like a good family and so on. And I mean, the people I work with over there they're my family for life, and like they're amazing people, but very different from here. Here it's more of a nurturing, okay, you can do this type of motivation thing, which I initially had a hard time because neither my family nor my education is like that. Like my mom is like, my mom is a geneticist as well. When I was in college, I had a class on genetics, and there was something I couldn't understand. And I knew that I wanted to be a scientist when I was 7 years old, because I used to go to the lab with my mom on the weekends and like thaw some solutions in my hands or whatever I could do to help her. And then in college, I go to this class on genetics, and then I'm like, Mom, I cannot understand this. Can you please explain to me? There's something here that I don't understand. And she's like, what, are you stupid? Why don't you understand? And I'm like, okay, this is the last time I'm asking you. So this is like the type of things that I came from. I'm not saying that this is how I am, but it was, for me, it was mostly trying to observe how people were, like what would they be their needs, and try to, I don't know, like help each other in a way that they would be able to receive it in the right way, I think. But I cannot really tell a managerial class or anything like that. I think it's all personal experience.
Yeah, and especially as people move into the industry, you find that, they learn quickly that obviously the academic world, the industry world, even though they have grown closer now and maybe are starting to blend a little better, it's still quite a different world. And you touch on something very important there, Amanda, because, scientists are not trained to be people managers. Scientists are nerdy people who sit at a bench with their pipette in their hand, a little tissue culture, and they compete with everybody else in the world, right? And we're critical of each other. That's how we're trained. We're trained to poke holes at each other's theories and each other's data, right? That's what we do well. But what we don't do well is the people skills stuff, right? Now, for some of us, it just comes more natural, right? Because, we're that kind of people, right? For others, it's a lot harder. And this has actually been a big challenge in the biopharma industry, especially in these larger organizations, because as you now grow up and you become more a manager and senior manager, now you're not in the lab anymore. Now you have to deal with strategy and all these things. And okay, maybe you're smart enough to do all that. But the people part is what often these managers struggle with. And I've seen this over and over again. They forget to take care of that part, right? Because now they're big shot, they're getting caught up into the politics, right? And they forget to manage the people. And it's incredibly important, right? So this is one thing that gets back to what you were asking for earlier, Abel, that, what should we be teaching these kids, or what should we be, teaching early in their career, right? I wish that people focus a little more on those kind of things, because I see it over and over. They come into this industry, they move up, they want to become managers, they want to become directors, but they have no clue how to manage a team. And I've seen this with people who've been in the business for 20 years, and they still don't know how to manage a team. Managing people is probably the hardest thing in the world, right? So unless you do it right, it is just not easy, right? I mean, you know how it is, right? I can manage people who are extroverts like myself. It's easy, right? I can be very direct. I can make a bad joke. but suddenly you have an introvert in your team, somebody who's soft-spoken, who is not into the whole Oivin shenanigans. I mean, it's not easy, right? So you have to learn these kind of things. And of course, some comes with over time, and some comes with, as Pinar said, having the right attitude, learning the right skills. But you know what? It's hit or miss with some guys, right? Or some people out there. And so it's not an easy thing for people, no matter in any industry, I think. But I see it in science all the time. The senior managers, the one thing they often fail at is people management. It's not a trivial thing.
Yeah,
for sure.
I'd say the same thing for people in biotech, or I should say academia, that's been there too long, or and jump into the business side, and it's a completely different beast, right? Because managing a business is not the same as writing a grant. And so you can have the greatest ideas, and I've been part of startups where best science, best people don't know how to manage your money, and there goes that there goes that startup. So yeah, I think there's a lot of things that I can point to that probably could improve, and we could probably do a better job at the academic level, undergrad, grad school, to fine tune the business skills, the business sides, and the social skills, the social science. And it does come a lot with mentors. And I always go back to Sumit, right? I think Sumit
mentors are key, my friend. You're absolutely right. It is so important.
I didn't have that one conversation with him that was here's your fork, my career, my life would have been completely different, and probably I wouldn't have had the success that I'm having now had I not had that conversation. So finding those mentors. Very I know important. We're a little over the hour now. I know this is like being back at Bellevue, so we can keep going and going, right? What did we miss here, Amanda?
Just if we were talking about collaboration, and a little bit, I mean, people are very interested in COVID. I mean, that's really what's on our mind. We've got civil unrest as well. And I think you touched on, they closed the border. So there goes my summer trying to get to Europe. So let's go back to COVID for a minute. And I know that the consortium has a big footprint in the collaborations that are going on around the Mesa. Are you guys involved in any of those projects?
I mean, I think everybody in the world is trying to, if they're not involved already, they're trying to get involved, right? And rightfully so, right? It's such an important topic, right? We need to, deal with this. And so it's interesting to me that you see when the world is hit hardest, people actually, tend to come together in ways that you had never even maybe imagined before, right? But yeah, and I'll let Pinar speak to this as well, because the academic world especially also has been leading the way with understanding the biology. But don't forget, the biopharma world has been leading the way with coming up with, trying drugs that might help till the vaccine is there. People forget that this vaccine is not going to be ready anytime soon. I don't care what anybody tells you. Okay, we need to survive till that time. And the biopharma industry, as much as they have a black name out there in the general community sometimes, really stepped up. Right now, a little plug for the biopharma industry, really stepped up and took all the existing drugs out there and start what we call repositioning, repurposing these drugs, and see, can we use them to help these patients that are in dire needs, and at least help manage the disease, manage the system till that vaccine is there. Now, had the biopharma industry not stepped up, it would be a different ballgame. But it's not to say that the academic world, what they're doing with, as Pinar said, papers are coming out every day. The underlying biology is not only fascinating, but it's actually quite challenging and changing, right? So you need a global footprint to tackle this thing, right? And so it's nice to see that people from all the world are really into this. I mean, every company that I know of, every academic lab I know of is trying in their own way to contribute. Pinar, what do you think?
Yeah, I think, this initially when this lockdowns happened, we had this Slack group from the Sanford from the building, and also with the campus, and it was incredible. All the PIs from the campus all over around the Mesa area, putting all the resources together, not only manpower but also reagents and everything. It was really a global effort, and it was amazing to see everyone coming in to kind of help with everything, because remember at that time we didn't even have a good testing for COVID yet. The CDC's testing were not working, and then they had to reconfigure and so on. So I think academia really helped holding the lines around that time. I know that in our building, Genio helped a lot. He was a leader in this to kind of defend and provide resources for this initiative. And I know also, like, for instance, in Burnham, so I think Sumit Chanda's lab has been trying all this different drugs. I mean, it's I think it's quite incredible. When it comes to research part though, like regarding this effect, like trying to do like the basic research part, not necessarily the drug repurposing and so on, it's a little bit more challenging because of the nature of this virus. We need a different safety, biosafety level. This biosafety level does not exist everywhere. We don't have that many places. We need a special training. Everything that come in and come out where the virus has touched, it's very well regulated. That kind of limits of the type of research you will be able to do. So maybe that's why we did not see that many things come out yet regarding the basic research. I mean, it's mostly patients and more people, it's coming from people who are virologists and like more specialized in this virus research. But yeah, I think we had that limitation, at least for people like us, to be able to work on that.
Yeah, I think that there's 2 points there. So to what you said, Oivin, I mean, the compounds that pharma has, right, when they don't, I think what the public doesn't realize is that, you know, when you're talking about 1.4 million compounds that are being screened on an assay right off the bat, that's decades and decades and billions of dollars of pent up knowledge and research in sitting on a library on the shelf, right? That you can just access to. And that's why you see immediate results, say on the pharma side. And then, you know, to your point, Pinar, I know firsthand about the BSL-3 stuff. I mean, I worked in a BSL-2+, and even that's, you know, a little bit dicey. But BSL-3, it's another level 4 we won't even get into. But the level of training required for that, I mean, Sumit himself, I think they were looking for somebody back in January. They just hired somebody for that's qualified to do BSL-3. So how do you get the research done if the people aren't qualified to do it? And if you're on lockdown, you can't hire a newbie because there's nobody there to train in EH&S. So all these issues that stop it. So yeah, you're really pushing, you put academia in a path that it comes to almost like a grinding halt without getting those BSL-3 labs prepped up.
And we didn't even have the proper PPE. Like I remember one of the initial lab meetings that we had via Zoom was actually telling about how little ethanol we had left in the lab. This is something that we use.
We drank it all.
Oh, yeah, because we have to sterilize everything. Not only
we won't name any names,
but also in the tissue culture room.
Sorry, back in my day. One for the cells, one for me.
Back in my days.
But that was like even the level that we were at, like we were really scared that we would run out of ethanol, and because like all these hospitals and I don't know if individuals were going and buying these bins of ethanol or masks or everything, like everything was in short supply at that time. So I think it really told us maybe in the country that we were really not ready for this type of an outbreak.
Yeah, no, I was on the LGI call with Erica Sapphire, and she was, you know, going over the, you know, State of the Union. And so you're talking about the you know, the molecular biology aspects, right? The finding out how the virus works, how it attaches. All these things aren't something you just see under a microscope, right? You're tearing these organisms apart into individual components and testing one at a time, one variable at a time. And then, oops, you know, the virus changes. Well, let's go back and start over and redo this, which it did February.
That's exactly what people don't realize, right? Well, it's science is challenging per se, right? But imagine doing science on a moving target.
Yeah,
right. Which essentially this thing is. And remember, along the way, we learned more and more and more, and some of it the hard way, right? I mean, suddenly we're like, people had no smell and taste anymore. They went delirious. Right? They had blood clots. I mean, nobody had anticipated that stuff, right? And so, you know, it is good that so many different groups with different approaches tackle this beast, because it turned out to be not simple an infection of the respiratory tissue, right? There's so much more going on, right? And this is where there's an opportunity for almost every group or lab, or company to contribute in their own way, and people do. But I think people didn't realize, kind of how different this thing is. You would talk about BSL-3. All of us have been reaching out to BSL-3 labs all over the nation, right? Because Scripps has one, but they can only do so much, right? So we all reaching out, and it turns out all the BSL-3 labs are maxed out.
Yeah.
Right, because as you said, they don't have enough people. They can't bring in new people easily, and everybody wants to work with them someday, right? So it was a challenge beyond just even the science, right? It's an infrastructure challenge. There was a strategic challenge in this country, and it really takes everybody to come together to tackle that properly. But I don't think people quite realize what they were up against.
Yeah, and I think if you talked about, you don't care about what anybody thinks, and as far as when this virus is going to get under control, and I think you're absolutely right. I think the expectation that the media puts out about, hey, we're going to get a vaccine, everything gets back to normal. It's like, look, how it's very rare that a company puts out one target, one compound, one vaccine, and you Hail Mary and it works, right? Yeah. But let's just say that is the case. Let's say it works the first shot. There's backup, but now you're talking about how long is it going to take to produce that? Make enough of this, antibody,
help everybody,
volume, consistently package it, syringes, vials, get this all distributed. And I think to Erica's presentation, it was like, it's not going to be available at all places at all time.
Right.
So then you've got pockets to get it first. And then who's going to take it? There's going to be a number of people that aren't going to be able to take it. Pregnant women, people that don't believe in it. So we've got to get to a certain percentage of people that adopt it, and then allow it to work. So you're still talking about a year plus on top of the day that they approve, the vaccine, right? So you're still talking, a year to 2 years past that till you can get to that point.
Yeah.
So I think
granted that I think everybody is on board. So of course everything gets expedited to some extent, right? For instance, the FDA. Right. Jumped on board, right? And now they are putting in rules and regulations in place to at least make it a more expeditious process, right? Because we're not bogged down by too much bureaucracy, which typically happens in a big country. That's just the way it is, because the challenge, right? I mean, again, we're not talking about 3 million people. We're talking about 300 million people plus in this country. I mean, how do you get to everybody everywhere all the time? So you have to work your way down, high risk group, and this kind of thing, right? Mm-hmm. So the medical professionals that are on the front line, of course, we need to protect these people first because they see the worst of it, right? And then you work your way in. So it's going to be in waves, right? You help the high risk ones and you work your way in. So it's going to be a while before everybody's got it. And then, the reality might be, just like we take our flu shot every year, we might have to take our COVID shot every year, right? I mean, pretty soon we'll have a cocktail of flu shots that we're taking, right?
They're going to put in Cheerios every week.
That's right. That's right. People forget that the bugs were here before us. Okay, let's not forget this, people, right? The bugs have been here before us and they will survive all of us. Okay, that's the way it is.
Yeah. Oh, well, I know this is one of the longer ones, huh, Amanda?
That's what happens when friends.
Are there any things you guys want to add? Anything that you want the public to know?
Any shout outs?
Woo-hoo.
Your fans that are watching.
There are so many of them. Where do I start?
Or messages, like, what do you want to tell the public? What do you want to tell people that are watching?
I think we touched on some important things, right? I mean, the public needs to understand, because I've seen it all out there now. Again, there's a lot of the articles, there are a lot of negativity again, right? Because the problem is scientist A says this, scientist B says that, right? But that is the reality of science, right? As you heard before already, it takes a long process. And often it takes 2, 3, 4 different labs or groups to reproduce the same result before we even believe it or fully believe in it, that we can build on it. So science is, again, it's like a moving target, right? So the public gets impatient because they're frustrated, and it's understandable. But they have to understand that these things take time. As I always tell people, you cannot speed up biology. You can't, it just works at its own pace, right? And we have to get smart about it. We have to stick our heads together and we have to work at it, and then we'll get there. But it's going to take time. In the meantime, guys, let's be careful and protect ourselves. There's nonsense about going out there, I'm going to just say it, without a mask, right? Or start gathering in big groups again. Come on, people, right? Haven't you learned yet, right? I mean, let's not do this stuff, right? Let's really work at it together and adhere to the rules. again, it's hard. We're 300 million people, right? How do you get everybody in every corner to adhere to the same rules? It's not easy. But unless we do it that way, social distancing, protection, PPEs, we're not going to keep this thing under control. So if there's one thing I can leave the public with, it's a very serious situation, but we can control it, but we have to stick to the rules. Let's help each other out, because they also start shaming each other for wearing masks. Oh, come on, right? Let's not do that, right? Let's stick to the rules, work together, and we'll get this thing under control.
Yeah,
and then I'll stop talking.
Stay away from a bar for 3 months.
That's right. Unfortunately, Bella Vista will have to do with us for a while, you know, so.
Yeah, I would just say, yeah, I mean, to kind of echo what Oivin was saying, I mean, I think, yeah, scientists, us, like we all have our specialization. We work for this our whole lives. Just, I know that sometimes people get frustrated because sometimes some information might change because we're getting more information about what's happening, what has been happening in retrospect. So then let's not forget about that also. And we're trying to adapt, and that's why sometimes the information keeps changing. So just trust the scientists. I mean, still continue reading everything and so on. But this, we've known about this for the past 5 months, but we already have some vaccine candidates. We already have some repurposable drugs. We already figured out several of the receptors of this virus. So, I mean, we might be impatient, but we still have discovered a huge amount of information in this 5 months by being under lockdown. Let's not forget about that. We're not having proper PPE.
That's right.
Proper BSL levels. And this is also why it's important to work internationally and worldwide all together, so we can all put our resources all together, and have an exchange of information about what they're seeing with their patients versus what we're seeing here. So this is very important. And also I don't know if you guys talked about this, but the SCRM initiative, so this is California Initiative for Regenerative Medicine, is on the ballot in November. Yeah, so if you guys like stem cell research.
Absolutely.
And if they have more questions about stem cell research, where can they direct those questions?
I think to our building.
Yeah. You know, there's plenty of people, I think, at UCSD and surrounding areas that can speak to that. We have so many fantastic institutions here, but also, the California, legislature, I guess, is pretty well aware of this, right? I mean, it's one of the few states where there's amazing support for stem cell research. So there's so many places to go in this state, but they can always start with a local lab or maybe the local bar, right? With the right people. Right. There's always plenty of us around that they can talk to, and we can then guide them to the right places. But there's definitely a big support for it, and we need to keep it that way.
Yeah, goes back to the funding, right? We got to vote for it.
That's right.
Vote the money in, get the funds to do this,
That's
and
right.
to prevent it from happening in the future, right?
Yeah.
Learn from this, right, and be better prepared.
Yeah, exactly.
All right. Well, I think with that, this is closing out episode number 10. Amanda, any last?
I just want to thank you for your time. When I got up to Bella Vista, I always felt, man, we need to tell the story of what you guys are doing. And it's just always been an honor and a pleasure. It started with, listening to you guys up at the cafe and then writing for San Diego Magazine. And this has always been kind of a pipe dream. And the pause from the cafe is given the space to actually, create Bella TV, and Abel, had faith. So thank you for jumping on board to just run with it. And I think, I always say, like, you guys are the rock stars. People are like, oh, why do you name dishes after your other people that come into the cafe? I'm like, because I want people to know who you are, right? Yeah. We don't need to just know about the Britney Spears, or, not that they don't deserve attention too, and fame and glory, but I think you guys are always the unsung heroes. So it's just been a pleasure to sit and try and absorb as much as possible of what you guys do. And let's just continue to, to have a platform to tell your stories to the world. And so get ready, we're taking a week off and we'll see where it goes. But get ready, because Bella TV is about to.
That's right. It's about to blow up.
Especially if I'm stuck in quarantine.
Well,
No, but thank you guys. This has been great. This is fun. Thank you for inviting us. I'm sure I'll speak for Pinar as well when I say that we really enjoyed this. It's been a fun discussion. And if you ever need us in the future, let us know.
Yes.
Now that we're well-known stars on Bella TV, now you can't do without us.
Be signing autographs. Anything else, Abel, before we jump offline and then we have a back.
Yeah, no, this is like I said, I've learned a lot from this. Even it being in the science field and the community, there's still so much to learn, and I've learned a lot from the different types of people and different types of scientists and medical professionals that came on the show. Really enjoyed the time. I think we're doing a great thing by disseminating this information and getting it out to the public. I know it can get a little geeky sometimes, but I think we've done a good job kind of keeping it to where the public can understand. I think that's what we have to do and hit that more often, day after day. Talk to your neighbors, your friends, and an outlet like this, I think, does the job. And I think the more we do it, the more it'll resonate and get it out. So,
Absolutely.
thank you, Oivin. Thank you, Pinar. Obviously, Amanda, thank you for allowing me to grace your screens for 10 shows. Not leaving and just taking a little side direction. We'll still be collaborating, I think.
Cool.
Oh, yeah. Big things are around the corner, everyone.
Yeah, I think you guys will like this that's coming up. It'll probably take a few weeks to get going, but it's almost there.
So
Great.
I'm trying to get you guys your crack fries soon.
So thank you guys. Thank you everybody for tuning in. Episode 10, and I guess we'll find out who will come back with episode 11. So,
yeah, cliffhanger. All right.
All right. Bye, everybody.
You guys stay on.
Peace.
I'm just gonna end the